Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is slope. In mathematics, slope is nothing but it helps us to describe the steepness and direction of the lines on a graph. By just looking at the graph of a line, you can learn some things that is about slope, especially relative to other lines graphed on the same coordinate plane. Let me show you an example. Please look at the graph. On the same coordinate plane, I have drawn three lines. Consider the graph of these three lines. First, let us look at the lines at A and B. If you imagine these lines to be hills, you would say that line B is steeper than line A. Line B has a greater slope than line A. Am I right? Okay, next, notice that lines A and B slant up as you move from left to right. We say these two lines have a positive slope. Line C slants down from left to right. Line C has a negative slope. So using two of the points on the line, you can find the slope of the lines by finding the rise and run. Generally, we used to find the slope using the formula rise over run. Or in case if you have two pairs of xy coordinates, then you can apply the formula to find the slope. We will be discussing that in the rest of the video. Before that, let us see what is meant by rise and run. Rise is nothing but the vertical change between 2 points, and run is nothing but the horizontal change. Generally, the slope of a line shows us where the line increases or decreases. Based on the increment and decrement, we can describe a slope of a line as a positive slope, negative slope, and there is one more type of slope which is called zero slope. Okay, let us first start with positive slope. When the slope is positive, it means that as we view the graph of a line from left to right, as x increases, so does y. So in this case, slope is greater than 0. It means positive slope. And second case is when the slope is negative, it means that as we view the graph of the line from left to right, as x increases, y decreases. So in this case, we write m is less than 0. M means slope. So this is called a negative slope. You can compare these two. Do you understand the difference between a positive slope and a negative slope? Okay, let us now see what is meant by zero slope. Do you see the third graph? When the line has zero slope, it will have a horizontal line. We will be writing y is equal to the constant, where the constant is nothing but the y-intercept. And we say that slope is equal to 0 here. So if you plug in 0 here, this term will vanish and you'll be left over with y equal to the constant. Hope you're clear with these three cases: positive slope, negative slope, and zero slope. So if you get a line in a horizontal way, it means it has no slope. Now let us see how to find the slope using rise over run method. Here is a graph. You can determine the slope of a line from its graph just by looking at the rise and run. One characteristic of a line is that its slope is constant all the way along it. So you can choose any 2 points along the graph of the line to figure out the slope. I have just picked these 2 points. This is the rise and this is run. Rise is 1 unit and run is 2 units. So 1 over 2. So that would be the slope here. Let me take an example and pick 2 points, and I'm going to apply the formula when the x and y coordinates are given. So hope you're clear with the rise over run method. One important key point here is the greater the slope, the steeper the line. For example, you have a slope like this, and if you compare it with this, you can understand the difference. So it depends upon the slope. Whatever height of the slope will decide the steepness of the line. Now let's see how to find the slope from 2 points of a line. So far you have seen that you can find the slope of a line on a graph just by measuring the rise and the run. You can also find the slope of the straight line without its graph if you just know the coordinates of any 2 points of that line. Every point has a set of coordinates, x and y coordinates. Am I right? It will be written in the order x, y. The x value will tell you where the point is horizontally because this is the x-axis, and the y value will tell you where the point is vertically. So to calculate the slope of the line, you need only 2 points from the line, x1, y1, x2, y2. And the equation that will be helpful for us to calculate the slope from 2 points on a graph, this can be represented as this. Here is the formula: y2 minus y1 over x2 minus x1. Hope you are clear with this formula. We denote the slope by m. So on a graph, consider these 2 points. Let these 2 points be A and B. A is x1 over x1 comma y1 and B is x2 comma y2. This is nothing but change in x1 to x2, horizontal, and vertical is change in y. There are actually 3 steps in calculating the slope of a straight line when you're not given its equation, just the coordinates. Step 1 is just to identify 2 points on a line. You can pick any 2 points. And step 2 is to select one of the point to be x1 y1 and other to be x2 y2. No problem even if you change the coordinates. You can also name this as x2 y2 and this as x1 and y1. And step 3 is to use the slope equation to calculate the slope. This is the slope equation. Okay. Let me take one example and explain how to apply this formula step by step. Here is an example. Let's say that the points 15, 8 and 10, 7 are on a straight line. What is the slope of this line? Okay. Step 1. Let's identify the 2 points on the line. In this example, we are given the 2 points directly, not the graph is given. In case if you get the graph, you can just pick 2 points on the line. Here, the points are directly given. So step 2. Select one to be x1 y1 and other to be x2 y2. So it doesn't matter which we choose. So let's take 15, 8 to be x2, y2. Let's take the point 10, 7 be x1 and y1. Third step is B. Use the equation, the formula to calculate the slope. Once we have completed step 2, we are now ready to calculate the slope using the equation of the slope. So what is the equation of the slope? Am I right? So y2 is 8, y1 is 7. 8 minus 7, and in the denominator x2 is 15, x1 is 10. So 15 minus 10. Let me plug in these values in the formula. In the numerator we'll be getting 1 and in the denominator 5. We said that it really does not matter which point we choose as x1, y1 and which to be x2 and y2. If you want, I can show that too. So let's show that this is also true if I interchange the coordinates. Let's check whether we are getting the same slope 1 over 5 even if we change the coordinates. So if y2 is 7 and y1 is 8, if I plug those numbers in this formula, I'll be getting 7 minus 8 in the numerator. Now the denominator, so 10 minus 15. If I simplify this, I'll be getting negative 1 in the numerator and negative 5 in the denominator. So negative divided by negative is positive, which is equal to 1 over 5. We get the same answer as before. Often you will not be given the 2 points, but we will need to identify the 2 points from the graph. So in this case, the process is the same, but the first step being to identify the points from the graph. Let me show you an example. Here is an example. What is the slope of the line given in the graph? Okay, first step is to identify 2 points on the line. Let's calculate the slope of the line in this graph using the points 1, 2 and 3, it'll be somewhere here, 3, 6, or you can just pick 2, 4, any 2 points. After identifying the 2 points, you can select one to be x1, y1 and other to be x2, y2. So let this be A be x1, y1, and let's take the point B to be the point x2, y2. Now let's apply the formula. Same concept as the previous example. So if you calculate, you'll be getting 4 minus 2 divided by 2 minus 1. Okay. So your slope will be 2. This means for each positive change of 1 unit in the x variable, the y variable will increase 2 units. Remember that you can choose any 2 point on the line to calculate the slope. You'll be getting the same slope. So using this graph, calculating the slope using the origin, you can also pick this as 1 point, 0, 0 and any 1 point. You can keep this as x1, y1 and keep the other point as x2, y2 and apply the same formula. Again, you'll be getting the same slope. Slope is 2. You will find that regardless of what 2 points you choose on the given straight line to calculate a slope. So your answer will always be the same. The slope for the given line is a constant one. Does this make sense to you? Now let's see how to find the slopes of a horizontal and vertical line. So far we have considered the lines that run uphill or downhill. Their slopes may be steep or gradual, but they are always positive or negative numbers. But there are two other kinds of lines, horizontal and vertical. So what is the slope of a flat line or a level ground, of a wall or a vertical line? So let me take one example. You can pick any 2 points as we discussed in the previous example. Let's first consider the horizontal line. Let me pick 2 points here. So these are the 2 points I have picked, -2, 2 and 1, 2. Did you notice that the y coordinates are same? y2 minus y1, the numerator is going to be 0. 0 divided by anything will be 0. So the slope of this horizontal line is 0. Let's consider any horizontal line, no matter which 2 points you choose on the line. They will always have the same y coordinate. So when you apply the slope formula, the numerator will always be 0. 0 divided by any non-zero number is 0. Am I right? So the slope of any horizontal line is always 0. The equation for this horizontal line would be y equal to 2. Telling you that no matter which 2 points you choose on this line, the y coordinate will always be 2. So how about vertical lines? In their case, no matter which 2 points you choose, they will always have the same x coordinate. Here I have chosen 2 points, 5, 3 and 5, -1. So what happens when you use the slope formula with 2 points on this vertical line to calculate the slope? Using the point 5, 3 as 0.1 and 5, -1 as 0.2, you'll be getting the denominator 0. Am I right? x2 minus x1 will be 0, the denominator. But division by 0 has no meaning for the set of real numbers. Am I right? So because of that fact, it is said that the slope of this vertical line is undefined. This is true for all the vertical lines. They all have a slope that is undefined. Hope you're clear with the concepts. In case if you have any query regarding this topic, kindly let me know.